Today we're going to talk about difference quotients. It's a scary sounding phrase, but it's not very hard. It connects to the idea of slope. So you should remember that the slope between 2 points on a line is change in y over change in x. Now what if we were talking about 2 points on some random function? Well, we can write this similarly, that we're still going to talk about the change in x and the change in y, but we can relate this x2 to y2 when we have the point x1 comma y1. That's the same thing as saying f of x1 equals y1. So instead of writing y1, we can write f of x1 and f of x2. And this is just a change in notation. We're saying the y-coordinate is the same thing as f of x. So f of x2 minus f of x1 over x2 minus x1. We're going to apply this to the definition of a difference quotient. Define. The difference quotient is the slope between 2 points on f of x whose x-coordinates are h apart. So let's pick an x-coordinate. So let's call that x. And that would be that this is x. So if we say that the x-coordinates are h apart, then we're going to have to go up by h to x plus h. So here we would find the point x plus h, comma, f of x plus h. And our original point would be x comma f of x. This is just saying that we have our original coordinate, we increase by h, and then we get our new coordinate. So the x gets changed by adding h to it, and inside the input of the function, we increase it by h. So, how do we find the slope between these 2 points? Well, that's what we just did on the previous slide. We say that it's y2 minus y1 over x2 minus x1. And we can simplify this. The numerator we can't simplify, but the denominator can be simplified because there are like terms. Specifically, the x's will cancel out, and we'll be left with this. This is the derivation of a difference quotient, and you should memorize that the difference quotient is f of x plus h minus f of x over h. And what it physically means is that it's the slope of this line connecting one point and a point that has a larger x-coordinate. This line we call a secant line, although we're not going to worry about that definition for now. The secant line's slope is the difference quotient. And you should memorize that the difference quotient equals f of x plus h minus f of x over h. How does this look like in a problem? Well, this gets used all of the time in calculus, and that's what pre-calculus is preparing you for. But the type of question I'll give you this year is more, find the difference quotient of f of x equals 2x squared minus 1. So first you have to memorize what is the difference quotient. I write dq, no, that's not Dairy Queen, is f of x plus h minus f of x. Sometimes people put a plus here, that's incorrect, over h. Now we have to plug this into our formula. So 2 times x plus h squared minus 1 is f of x plus h. Now you see why we did so much with that. 2x squared minus 1 is f of x, and then we do this all over h. So what I've done, I've taken x plus h and substituted into f. I've taken x and substituted into f, and now I'm going to subtract them. So order of operations says we will do our squaring first. X squared plus 2xh plus h squared. This is where it's really useful if you have already memorized your perfect square trinomials. Now let's do the distributive property. We get 2x squared plus 4xh plus 2h squared minus 1 minus 2x squared plus 1 all over h. Where are our like terms? I see positive 2x squared and negative 2x squared add to 0. We also have negative 1 and positive 1 add to 0. So we're left with 4xh plus 2h squared over h. And these are both divisible by h, so we can divide out h and get 4x plus 2h is our difference quotient. Really, all you're doing is remembering the definition, substitute the function, substitute into the function, and then simplify, and you'll get your difference quotient. That's it. Thank you.